Hello everyone, in this video we're going to talk about logic gates. Now you may or may not be familiar with logic gates, you may have heard them in the past but you don't really know what they are. So in this video we're going to cover three different types of logic gates. We're going to cover the NOT gate, the OR gate and the AND gate. There is some other gates out there but for this course they're not relevant and we don't need to know them. We've got three different types. Our NOT is represented by a symbol like this, so it looks like an arrow on its side with a circle at the top. Then our OR looks a little bit like a spaceship or a out of shape D, and our AND logic gate looks like a D. So you might be thinking, what exactly does a gate do? So similar to real life, a gate stops something from entering. So we might use a gate to stop somebody entering our property, or we might leave a gate open if we want to allow people to enter our property. So similar with our logic gates allow stuff to come in and they prevent stuff from coming in. And the stuff that they're preventing is actually a current, but we'll get to that later. Again, this video is just a high level overview of what we're going to be covering. So if there's things that you're not quite sure on, don't worry about it. We'll be going into detail in the next coming videos. So we can think of a gate as something that performs some operation or some function. So you can imagine this gate as a box, and when you put something into this box that it produces an output which is always the same. For example, when you put food into the microwave, it's cold, and then when you take it out, it's hot. So you don't know exactly what's going on inside the microwave, all you know is it heats up your food. So in a similar way, we can provide input to our gate. So the input that we could provide could be a binary number, so it could be 1 or 0. And it can take in not only one binary number, but many binary numbers. So we can just think of this as an input. And then we receive our output. And our output can be a binary number also. It can be 1 or 0. Now I would suggest, if you're not familiar with binary, to go and look at our binary videos before we jump into logic gates, because it can help you understand what's going on. But it's not a must. We'll be going through all in detail in this course anyway. So now we know that there's three different types of gates. There's a NOT gate, there's an OR gate, and there's an AND gate. And these different types of gates all do something different. We'll not worry about what they do yet. All we know is that they do something different. So for example, if I give an input, so let's say my input is maybe a binary number, so let's say it's 1 or 0, and I give my input to a NOT gate. So my NOT gate here will receive the input, it'll do some operation, so it'll change the data that I give it, and it'll give me some output, and the output it will give me will be a binary number as well, so it'll be a 1 or a 0. Now if I give that same input using a different gate, so if I was to use some binary numbers and use an OR gate, I would get a different output even though I gave the same input. I could give the exact same input to an AND gate but get a different outcome or a different output. So another thing you might be thinking of is, why do we need this? Why do we need logic gates, or why do we need these different type of logic gates? And the reason is, by using multiple logic gates, so we usually don't use one logic gate by itself to do something, we usually use multiple logic gates. So we could use a NOT gate and an OR gate and an AND gate and maybe another OR gate, or a simpler example might be us just using a NOT gate and an OR gate. And what this allows us to produce is a switch, or some people call it a flip-flop. And basically what it does, it allows us to change our bits, it allows us to flip our bits. So if you think of a real world example, like maybe in your room you have a light, you flick the switch on and off and your light either comes on or your light gets turned off. So to you know that switch will just switch your light on and switch that light off. But behind the scenes there's a lot more going on. What's happening when your light is turned on and is in the on position, current or electricity is allowed to flow through the wire, and that produces the light that you see. Then when you hit that switch to turn the light off, that circuit is broken. So it's not a complete circuit, so it no longer lights the light bulb. So from this small example that I've drawn out, don't worry, you won't have to remember this. This is just to try and give you a better understanding of the previous example. So with anything we need a power supply. So to light up a bulb or an LED, we need some sort of power supply. So our power supply could be like a battery, so a battery that goes into your remote control, or a battery that goes into your car, or it could be a power supply like the electricity that's supplied to your house. So we've got a power supply. Now our current will run from positive to negative, so we're just going to draw in these little arrows to represent how the current is flowing. So we can see that the current is coming up, it's going across, it's going down, and it's meeting back up here, and this is completing a full circuit. And we can see we've got this little thing here. It looks like a triangle on its side with two arrows pointing out of it. This is just to represent LED, or we could have a bulb here or whatever. Just imagine this as a light. So when we've got this all connected together and we've got a complete circuit, our bulb will light up, or our LED will light up. Now, for whatever reason, if we wanted to stop this LED from lighting up, we would need to break the connection. So we would need to put a break in here, and then our LED would no longer light up. The problem is, if we then want to get our LED to light up again, we would need to rewire our circuit, or we would need to connect these two wires together somehow. Now that would be a pretty big problem if we had this in like a house or something like that. So this is where we have a switch. So a switch comes in, and a switch we can just place in here, and we can see that this switch is currently off. So we can see this circuit is no longer connected. But imagine that we move this switch and we connect it here. Now the current is allowed to flow. So our light bulb, or our LED, will light up again. Now, to take a deeper look at these switches, we use things called transistors. And I'm not going to get into it in too much detail because it's not really needed for this course, but I'm just going to draw a quick diagram. So if we look at this, we have our current over here on the left hand side, and our current is always flowing. So let's say it's always on. So the blue represents that current. Now we can see with our transistor here, our transistor will also have to be on for our circuit to complete. So if it's not on, then our current here will never be able to get to this next wire here. And we can imagine that there's an LED out here that's going to light up. So if our transistor is off, which it currently is, we would not be able to light up our LED over here on the right hand side. But imagine we turn our transistor on. So we have our blue line, and now we have a current going up here, and we turn our transistor on. So now all that current is allowed to flow to this other wire on the right hand side, and now we can go and light up our LED or our bulb or whatever. So again, don't worry if you didn't understand everything in this video. What we're going to dive into in the next couple of videos will be our types of logic gates. That's what we're going to focus on mainly. So if you don't know about current or electricity or switches and things like that, don't worry about it. This video was just trying to give you a practical perspective of why these logic gates are used and how they're applicable.